Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 12, 2026, about 2 weeks ago. It introduces a new framework called QRRanker that uses internal attention scores instead of text generation for re-ranking, establishing a new state-of-the-art on the Locomo benchmark with an F1 score of 57.3. The paper is titled Query-Focused and Memory-Aware Re-Ranker for Long Context Processing. And as we'll see later, the fact that it achieves this with a compact 4 billion parameter model is really impressive. You can find the 3 billion parameter QRRanker weights on Hugging Face. The page also provides Python code and JSON examples to help you start re-ranking your data today. Figure 1 illustrates exactly how these internal attention scores translate into a ranking. The grid represents the attention map of a specific head in the model. We focus on the rows corresponding to the question at the bottom, looking at how strongly they attend to each document column above. The model sums these attention values, shown by the blue boxes, to generate a raw score for each text. In this example, Doc 2 is the gold document, so it naturally attracts the most attention, resulting in the highest score, S2, at the top. Figure 2 expands this concept into the complete system. The central panel details the QRRanker model, where specific attention heads, highlighted in orange, compute relevant scores between the question and the documents. To support long inputs, the memory construction module on the left generates summaries for narratives and dialogues, providing essential context without overloading the system. Then, the pipeline on the right ties it all together, retrieving an initial shortlist, augmenting it with memory summaries, re-ranking with the model, and finally passing the top results to a large language model to generate the answer. So, Table 2 presents the retrieval and re-ranking performance specifically on the Locomo benchmark. The first 2 rows display the baseline embedding models, with the fine-tuned SFT embedding 8B scoring about 76% on recall at 3. Interestingly, the much larger group rank 32B model only reaches about 78%. In contrast, the bottom rows show that the proposed QRRanker achieves the highest performance with 87.3%. This represents a massive improvement of over 11 points compared to the fine-tuned embedding baseline. Now, Table 1 broadens the scope to Wikipedia and narrative question answering. The top section lists standard embedding models, while the middle block compares competing re-rankers like HippoReg and the massive group rank 32B. Looking at the bottom row, QRRanker 4B consistently takes the lead. For example, on the narrative QA dataset, it achieves a recall at 10 of about 55%, significantly outperforming group rank's 49%, despite being a fraction of the size. Next, Table 3 moves beyond simple retrieval to evaluate actual downstream performance on the Locomo benchmark. The authors compare their method against a wide range of state-of-the-art memory and agent frameworks. The fine-tuned SFT embedding baseline achieves an overall F1 score of about 51.6%. Other systems like CompassMem reach comparable scores, but often require massive inputs, up to 20,000 tokens. In contrast, the bottom rows show that QRRanker dominates while using a compact input of just 854 tokens. It achieves an F1 score of over 57%, proving that precise re-ranking can outperform complex memory mechanisms. Finally, Table 7 highlights the practical benefits in speed and compute. The first 2 rows show the baseline QN3 re-ranker, which requires over 115 teraflops per query and has a median latency around 1200 milliseconds. In contrast, the third row shows that the standard QRRanker drops the compute cost to 83 teraflops and improves latency to under 1100 milliseconds. Most impressively, the bottom row presents the truncated middle variant. By cutting off the upper layers, it slashes latency to 910 milliseconds and reduces compute to nearly 70 teraflops, making it a highly efficient solution for real-time applications. Wrapping up, the key takeaway is that we can achieve state-of-the-art re-ranking without expensive text generation. By using internal attention scores, QRRanker outperforms much larger models on complex long context tasks while cutting compute costs significantly. This offers a promising, lightweight direction for future retrieval augmented generation systems. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.